types of systems and types of thermodynamic properties. Today we are going to study zeroth law of thermodynamics. Before studying zeroth law of thermodynamics, we should be very well aware of thermal equilibrium. Now when we study thermal equilibrium, there are two things, those are very important to know. One is temperature and second is the heat. So what is temperature? Temperature is the property of material due to difference of which heat flows across the material. And what is energy? Energy that flows from, it is the energy that flows from one system to the another due to the temperature difference. Okay, so these are the definition. Let us understand its meaning with the help of example. Let us consider a rod with end A at temperature T1 and end B at temperature T2. Okay, so now if we consider these two temperatures are different, that is suppose T1 is greater than T2, then what will happen? Natural process is temperature T1 will decrease and temperature T2 will increase. What does it mean? Some kind of energy flows across this rod from end A to the end B, that is from higher temperature to the lower temperature. So the kind of energy that flows across the rod is called as heat. So what is temperature? Temperature is the property of this material, okay, this rod. And what is heat? Heat is energy flows across the rod due to temperature difference. Now instead of considering these two different temperatures, if we consider these two temperatures to be same, that is for example only T, then what will happen? There will be no heat flow across the rod. Definitely, because energy flows across the rod if and only if T1 and T2 are different. So these are the meanings of temperature and heat we should always remember. Now let me move further and consider system A is at temperature T1 and system B is at temperature T2. Both the systems are separated by an adiabatic wall. So what is the meaning of adiabatic wall? Adiabatic wall is the wall that does not allow transfer of any kind of energy across the boundary. So this wall itself acts like a boundary between system A and B. So these two temperatures are different. So T1 is not equal to T2. At the beginning also this is the situation, and even if you note down after some time, then also we will observe the same situation that T1 is not equal to T2. Why this is so? Because adiabatic wall does not allow interactions between system A and B. Now if we just replace adiabatic wall by diathermic wall, what will happen? In that case, system A interacts with system B. So diathermic wall allows the energy transfer across it. And therefore, even if temperature T1 and T2 are different at the beginning, then after some time, there will be energy transfer across system A and B, and temperature of both system will become same. So, irrespective of which one is greater. So, if T1 is greater than T2, energy will flow from system A to B. And if temperature T2 is greater than T1, then yes, temperature energy flow will take place from system B to A. Okay, so this is the difference between adiabatic wall and the diathermic wall. And whatever equilibrium is reached here is the equilibrium in respect of temperature. And therefore, this equilibrium is called as thermal equilibrium. Now for understanding, we considered system A and B, that is two systems we considered. Even if you consider system and the surrounding, and if there is a temperature equilibrium take place, then there also we can consider that system is in thermal equilibrium with the surrounding. So same is the case for two systems as well as for system and the surrounding. So this thermal equilibrium achieved is the basis for zeroth law of thermodynamics. How? Let us see. Now earlier we considered only two systems. Now let me consider three systems. System A at temperature T1, system B at temperature T2, and system C at temperature T3. Now what is the difference here? A and B are separated by an adiabatic wall. So I have used the same color. And system AC and system BC, these are separated by diathermic wall. So now what do you expect here? We expect that there should not be any interaction between system A and B. But across A and C, there will be definitely an interaction take place. Also across B and C, there will be energy transfer take place. So now you see these three temperatures are different. T1 is different than T2 and T2 is different than T3. So though system A and B, these two are not interacting with each other, but these two are individually interacting with system C. And what you will observe after some time? So there will be energy transfer across A and C, there will be energy transfer across B and C, and after some time temperature of all these three systems will become same irrespective of the fact that there is an adiabatic wall between system A and B, and there were no interactions between system A and B. So this is what is the zeroth law of thermodynamics. So zeroth law of thermodynamics considers three systems: system A, system B, and system C. So how it is stated? It states that when two bodies or system are in thermal equilibrium with third body or third system. So if we consider that system A is in equilibrium with C and system B is in equilibrium with system C, then these two bodies are in equilibrium with each other. So it means that when two bodies are in equilibrium with the third system, then those two bodies are also in equilibrium with each other. So we can either consider it as a bodies or we can consider it as a systems, no doubt. So this is what is zeroth law of thermodynamics, which is based on thermal equilibrium concept. So this is all about the zeroth law of thermodynamics. Thank you.